Hello, my name is John Biltcliffe and I'm an industry specialist solution architect at AWS, and this video takes you through our fast turnaround workflow demonstration using TAMs. For those of you not familiar with TAMs, TAMs is an open source API specification released by BBC R&D. It describes how you can use small chunks of video stored on object storage, and then the API describes how that content is put together. So using a data representation very similar to NMOS and JTNM of flows and sources, the TAMs API allows you to hold content and through the API describe what resolutions, renditions, bit rates are available and how it is stored on object storage. And because it's small chunks of video, we can then start doing clever things like being able to read those as soon as they've been written to the store and be notified through event notifications that content is now available, giving the effect of growing content, but using standard object storage. And because those small objects are available to be used, you can then start doing things like if you have a source A with its chunks of media and a source B with chunks of media, you can then start combining them in an edit by reference workflow to create a new source C, made up of those existing chunks on the storage. So you can create lightweight edits in the store without any duplication of media. So this enables workflows to be much faster and more optimized than traditional workflows. And of course, we can then use cloud-based capabilities or spinning up and down resources to end up with something that is far more cost-effective for customers doing these sort of workflows. The other benefit of TAMs is we believe a single store can be used for multiple different purposes. So in this example of a single time addressable media store being used for a news press conference, though that's ingest can then be used for live production, so straight into gallery playback, for example, onto a news channel, into post-production to create packages for an evening news, clips out to social media very, very fast because the social media teams can be accessing the same sources, and as soon as they're ingested and as soon as the media is available, they can clip that and export that for social media. TAMs is very close to things like HLS and Dash, and therefore you can convert the TAMs API into manifest in a very lightweight transformation, and so your TAMs store could potentially be an origin for streaming for websites and apps. TAMs is also very applicable for live AI analysis. Most of the models out there don't understand video as a stream. What they understand is files, whether that's images or video. And TAMs is made up of lots of small video files and media files that are well represented in terms of timing and identity and perfect to be passed into those sort of models for analysis. And finally, content can be used in a TAMs store for syndication from one company to another. And we have a separate demonstration around how we can do that for near live distribution of media in a news environment using TAMs. And so if that's of interest, I recommend you going and watching that video. So this demonstration really focuses on that kind of core fast turnaround workflow, doing ingest through tools like Zixi and TechX, making that available in MAMs such as the Mimir MAM, and also be available in our guidance for a Media Lake on AWS guidance site. We can export that content through our own elemental media convert transcoder, which is capable of reading directly from a TAMs store. And we also have tools for generating proxies and exporting using FFmpeg and Lambda. We have high-resolution video playback using Matrox Origin to be able to read from the TAMs store and output that in a variety of video formats. Matrox is also capable of ingesting video into TAMs, but we're not using that capability within this demonstration. We also have the ability to go and edit the content at a variety of levels. So our TAMs tools UI, which we'll see in a minute, has the Omakase player embedded in it to do simple clipping workflows. If you need a timeline, then Cutting Room, web-based edit platform, is able to read from a TAMs store and present both ingested and ingesting content on the timeline there for editors to go and cut with. And for craft edit use cases, then Adobe Premiere can access a TAMs store using a plugin from Drastic Technologies. So let's have a quick look at some of that demonstration. So I'm here looking at our AWS TAMs store. The implementation of TAMs is an open source version that we have put out on GitHub to help customers and partners get going as a reference implementation. In addition to that, we've also released the TAMs tools repo, which is a set of TAMs capable tools to help customers and partners start to build their environments. So the UI that you're seeing here is one of those. We have some ingest tools to be able to populate a store very quickly. We have FFmpeg tools for creating proxies and exports out of the systems, and an integration with MediaConvert to trigger exports to a whole range of different formats here. And this is really about enabling customers to very, very quickly deploy a store with some usable tools to start playing and testing some basic workflows here. And then from there, you can then integrate other tools and build out a much richer ecosystem very quickly and easily. So I can view my store and come in here and see all my content. I can search and dig down and find content that's available for me. There's a function to be able to view the diagram here. This is the same kind of data structures we saw in the PowerPoint. I've got a video, I've got a source that's a piece of content, I've got video, images for thumbnails, and audio elements to it. And then underneath that, you can see the actual flows, the different renditions of videos. So here we've got the original high res and a 1080 and a 720 proxy of that. And they link together to represent the same content, as well as the thumbnail images we'll see in the UI in a minute, and the audio for this content. And that's a fairly typical TAMs structure. You can have more audio if you've got more audio tracks, or more video if you want different resolutions, frame rates, bit rates. The TAMs API is agnostic to all of those. You describe when you create your flow what it is you are going to store within TAMs. I can come back and I can then view a player here. And this is the Omakazi open source player that we're using. So I can at the bottom here see the thumbnails representing the content that was generated as one flow, and then here are the different flows and the segments. I wouldn't expect a user to usually see this view, but it's very handy for demonstration purposes that you can see the different segments and the different flows in the workflow here. And I can go and play this content back, and you can see it in the browser here coming straight from the store. But I can do things with an Omakazi, like creating simple edits. So I can go and create a section where I want a few segments from here. I can go and create a second section within the player here. And then I can go and say, export this. And I've got a few different options available to me. I can go and trigger MediaConvert with its TAMs capability, ability to read the TAMs store. It will take the sections here and transcode them to whatever format you want. You just need to drop the MediaConvert JSON definition in here, and they support all the standard VOD and broadcast formats out that MediaConvert supports. I can also go and do a flow creation here. This will do an edit by reference. I'll give it a label to describe what I'm doing, and then click on the export. And what this will do is go and create a new sources and flows within the TAMs store to represent the new edit that I've just created. But it will then link to these existing segments in the store, creating me a very simple edit of these two clips combined without duplicating any media. So just purely a metadata edit by reference. So I go and look now, I've got video demonstration here. I can go and look at the player, and I should have my edit here on the timeline that's now perfectly playable, that represents that. Again, all of that without duplicating any content, just pure metadata edits. And I said earlier we can then start plugging in other tools into the store. So we've got a TechXTX Darwin here that is ingesting content into our store, so it receives it via SRT, splits it in the audio and video because TAMs we recommend having separate essences in there, and then writes that as segments into the store. This is really nice because it just takes the original essence, wraps it, and puts it into the store without any transcode or re-encode. So from a quality point of view, what you're using as your contribution is what you will end up in the store. There's no re-encode, encode, decode kind of cycles going on here, which also makes it much lighter in the compute requirements and much more efficient in that sort of way. So this is Cutting Room web-based edit platform. They have an integration with TAMs here, which is my Dublin demo CNAP store. I can then see my content, and up here I can come along, I can view the content, I can mark in and out points as you'd expect, and then drop them down the timeline as edit points, and build up an edit on my timeline here. They also support a live mode, receiving the TAMs event notifications, so you can drop live content onto the timeline and see it grow in real time. There's an integration with Mimir, MAM platform, to be able to ingest content into their store. So again, I can search here for my content and find it, and they will read it directly from the TAMs store, so we can see the duration here. And again, same content available playing back in the browser from their store. And we can see some of the metadata that's been replicated up, the title, and you can replicate other metadata up into here as well. And then this is available to use within the Mimir interface and their tools. So this is how we would expect users to actually interact with the TAMs store, is to use tools, the tools they're used to, like Mimir, to be able to search, find content, work with it, where TAMs is providing the underlying storage and ingest capabilities for them to go and use. We will also have playback in other tools such as the Matrox Origin product to be able to play back into broadcast video, which I can't show you within this video, and integration into other tools such as our guidance for Media Lake on AWS. So to wrap up, for those that are interested, there's a second demonstration available looking at how we can do replication of media for news content across a number of TAMs stores. So please look for our near live content distribution using TAMs demonstration for more information on that. And finally, if you're looking for more information on TAMs generally, then please go to timeaddressablemediastore.org, and you'll find all the resources, links to the different GitHubs and the implementation guides there, as well as information on the TAMs community. So thank you very much for listening.